Have you ever wondered how geologists determine the age of rocks which formed when they were no there? Worry not, because I got you covered. Well, these people uses what we call principles of stratigraphy to know which rock layer came first or last. But wait, I am sure you know what I am about to say. Please subscribe, like, comment, share, and ring the bell to be notified each time we upload new content. This is MJ School of Mining and Geology, the only institution striving for excellence. Enjoy! The principles of stratigraphy are defined as principles on which the stratigraphic studies are based. This include order of superposition, original horizontality, lateral continuity, cross-cutting relationships, inclusions, fossil succession, and uniformitarianism. It is essential to understand the basic principles of stratigraphy so that you can interpret the history of how the rocks were formed and what was the kind of sediment and the type of the basin where deposition took place. This states that the present is the key to the past. In other words, the same natural laws which operate in the universe today have always operated the same in the past. Geologists now realize that this is not entirely true. The early atmosphere, for example, had quite a different composition to the atmosphere today. For instance, there was no free oxygen in the early atmosphere, and this allowed the deposition of gold deposits in Archean times. This could not happen today because the gold would be oxidized. Oxygen levels started to build up only after photosynthetic plants appeared. This is the fundamental concept of stratigraphy, which states that the youngest layer of rocks is at the top and the oldest at the bottom. This assumption can be overturned literally by tectonism. For example, when rocks are faulted during a tectonic deformation, then footwall and hanging rocks moving relatively to one another may cause the opposite to be true. In this case, various way-up criteria, usually sedimentary structures, can be used to establish the correct way up. For instance, worm burrows and other trace fossils go down, not up. Rock fragments from older strata may be incorporated in younger strata, but clearly not the other way around. A fragment of a rock incorporated or included in another is older than the host rock. Likewise, the pebbles in a conglomerate have been eroded from a rock unit that is older than the conglomerate. This also applies to fragments of rock found in igneous intrusions, xenoliths. For example, a fragment can be incorporated by magma on its way up. As the magma cools and solidify into a new igneous rock, this results in a fragment being older than an igneous rock that included it. Strata extend in all directions until they either thins and pinch out, grade into a different kind of rock, or end abruptly at some kind of contact. This means the sediments were initially deposited laterally in all directions until cut out by the river or valley or being eroded. Thus, when you are on the other side of the river/valley, you assume if it was not by this river, these layers were going to be one. Water-laid sediments are deposited in strata that are horizontal or nearly horizontal and parallel or nearly parallel to the Earth's surface. This means that inclined or overturned beds must have been disturbed by tectonic deformation as they were originally horizontal. In an area of deformed rocks, it is important to establish the way-up or younging direction of strata to correctly interpret its geological history. There are, however, a few exceptions to this, such as slumping of deltaic beds. This states that igneous intrusions and structural features, such as faults, are younger than the rocks they cut. Wait, think about this in this way. We are always baking the cake first before we could cut it on our birthdays, not the other way around. Thus, cutting always happens at the later stage. Groups of fossil organisms occur in the geological record in a definite and determinable order, and geological time can be recognized by its characteristic fossils. This principle is based on the fact that organisms evolve through geological time. Particular types or organisms existed for only a limited time in geological history, whereas particular organisms only occurred during that time. For example, rocks containing dinosaur fossils always occur stratigraphically older than those containing hominid fossils, but are always younger than those containing trilobites. In conclusion, the principles of stratigraphy help us understand the relative age of rock layers. However, this relative dating does not provide actual numerical dates for the rocks. Thank you guys for joining us today. Until next time, cheers.